Now that we know about graphing absolute value equations and graphing linear inequalities, we can put them both together to graph absolute value inequalities. So how do we go about doing that? Well, the 3 steps for graphing absolute value inequalities are the same as they are pretty much for graphing linear inequalities. Just that our first step is to graph the V. Absolute values have that distinctive V shape, so we want to put that V in the right spot. The next thing we want to do is to determine whether we're going to have a solid line or a dotted line. And that works the same way that it did before. That is, that if we are dealing with less than or greater than, that would mean we have a dotted line. And if we have less than or equal to or greater than or equal to, that's going to mean we use a solid line. The last thing that we have to worry about, of course, is shading. And we're going to determine that by testing a point. All right, so let's try this out with a nice simple example here. Y is greater than or equal to the absolute value of x minus 4. So our first step is to get the V in the right place. And of course, that all comes from our vertex. Our vertex is going to be that point of the V. The x-coordinate of the vertex is the opposite of what's being added inside the absolute values. Well, we don't have anything in there. And the same as what's on the outside, that's what's our y-coordinate, so negative 4. So our vertex is going to happen at the point 0, negative 4. Since we're multiplying that absolute value by a factor of 1, that means we have a slope of 1 on each side. So to the right, we're going to have a slope of 1, and to the left, it'll be a slope of negative 1. But we do need to determine whether it's going to be a solid line or a dotted line. And that's going to come in right here with that inequality. Because we're dealing with y being greater than or equal to that absolute value of x minus 4, that means our lines that we're going to use are going to be solid lines. Anytime we have that or equal to, that's where we'll have our solid lines. All right, so now we have our V is in the right place. We also have the boundaries being a solid line because it can be equal to. Our very last step then is to determine what side we shade on. And we can do that by just picking a point and testing it. The easiest point to test, of course, is 0, 0. We plug 0, 0 in. Our y-coordinate is 0. Our x-coordinate is 0. And we just have to see, is this correct? Is 0 greater than or equal to the absolute value of 0 minus 4? Well, that would be negative 4. Is 0 greater than negative 4? Yes, it is. That means that that's going to be the side that we shade on inside this absolute value. If we were to test a point outside of that, we could pick anything. Maybe, how about this point? This is the point for negative 4. If we tried that, we would have that negative 4 is greater than or equal to absolute value of 4 minus 4. So is negative 4 greater than or equal to 0? No. And that's why none of our solutions are going to happen outside of that V. In this case, all the solutions are inside. Let's get a little more practice with one more example. Y is less than 2 times the absolute value x plus 1 plus 3. Of course, the first thing we want to find is our vertex. Again, our vertex has an x-coordinate and y-coordinate that depends on these two numbers. The x-coordinate is going to be the opposite of what we see on the inside, so negative 1 instead of that plus 1. And the same as what we see on the outside, so plus 3 means our y-coordinate is plus 3. So our vertex happens at negative 1, positive 3. Right here. Then, because the absolute value is being multiplied by that positive 2, that means the slope on the right side is going to be 2, up 2 over 1. And on the left side, it would be the opposite of that. So we would have something like this. Here is our V. Okay. Now, we do need to determine whether that V should be drawn with a solid line or a dotted line. And that's where our inequality comes in. Because that is y is less than and not equal to, that means that our lines that we're drawing should not be solid lines. Instead, we should draw them with dotted lines. Like this. Lastly, we want to determine which side of our graph we're going to shade. So we pick a point, again, since 0, 0 is not on our curve. Why don't we test that one and check it out. Is 0 less than 2 times the absolute value of 0 plus 1 plus 3? Well, 2 times the absolute value of 0 plus 1 is 2 times 1, which is just 2. And 2 plus 3, of course, is 5. Is 0 less than 5? Sure is. That means that we need to shade on that side of our curve. Which means our graph is going to look like this, with the V opening up, vertex at -1, 3, and shading outside of that V this time.